Okay, say we have an alkene. And we reacted with NBS. Well, NBS essentially allows us to have free bromine radicals in solution. And these bromine radicals interact with the hydrogens on these alkenes at the allylic positions, the positions 1 carbon away from the double bond, and they give us new radicals. So to demonstrate that, I'm going to actually show the same molecule 4 times. We have one hydrogen here that it can interact with. We actually have 2, but we're going to talk about 1 for now. And in this case, we'll show the same thing, 1 there. But on these 2 molecules, which are all the same, it could interact with a hydrogen on this carbon, which there are 3 for it to pick from. So what happens is this bromine radical, and I'm going to draw it right here, this bromine radical, the electron essentially forms a bond with the electron on the hydrogen, and we give that electron, the other electron between the hydrogen to the carbon. So essentially we split the bond between the carbon and the hydrogen and made a new bond between the hydrogen and the bromine. That leaves the new radical. Now we still have more bromine radicals floating in solution, and these bromine radicals can have a termination step with this radical here, forming a new bond. Like this. And that's a double bond there. And that's one product from this reaction. However, there's another reaction. So let's look at, or another mechanism. Let's look at this right here. So we have a bromine radical floating in solution. It breaks the bond between the hydrogen and the carbon and forms one. So we'll draw one Fisher arrow, one there, and this arrow here. So now we're putting the radical on that carbon, and I'll draw that. And we still have more bromine radicals floating in solution, so we're going to do another termination step with these right here, giving us the final product of it's a terrible looking lines there, sorry about that. So that's great, but as you probably noticed, I drew 2 more molecules, and we have 2 kind of obvious products, but we have a little bit of a less obvious product that arises from resonance. So again, we're going to have the same first interaction. We have a bromine radical come up, and we have it interact with that hydrogen, breaking the bond, placing the radical on the carbon, giving us that radical. And as you can see, this is the same as that was. So that's all we're talking about. What happens is this radical resonates in between this carbon and that carbon. This double bond breaks, forming a new double bond, and the other electron in that double bond now rests on that carbon there. So we get a new radical. Is our new double bond and our new radical. Then we just have the same thing happen before, as before. The bromine radical forms a new bond with that radical in a termination step, and we get this product. We have one more situation to look at, and that's this situation. So our bromine radical from NBS comes in, interacts with that bond, and breaks it, the bond between hydrogen and carbon. The carbon gets the lone electron. And we have some resonance, and I did not draw this very well, but in fact I'm going to draw that a little bit better. We have some resonance. So one electron from that double bond goes to that carbon, the other goes between those two carbons. Now a radical goes in and makes a new double bond, giving us that radical. We have bromine in solution interact with that radical in a termination step, making the final product. And that's how NBS works on allylic positions on alkenes. 4 products.